Rationalization, a very important concept which we'll deal with the help of 6 examples. As you can see, wide variety of examples we have taken here so that you get the complete concept. We will be rationalizing both denominator and numerator as the case may be. So here are 6 questions for you which you can answer and then look into my solution. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Rationalization, as you know, is a very important technique which we are going to master with 6 examples in this video. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Let me thank all the viewers and subscribers for watching my videos and posting excellent comments. Based on your suggestions, we take new videos almost every day for you. Now let's look into the solution of these problems, which basically is rationalization. So we'll begin with the very first question, which is a over square root b, and then part b here is a over b minus square root c. We'll get the concept and then take up the next 4. Now in the very first part a, we have a over square root b. Normally, if you're writing an answer, irrational number square root b should not be there in the denominator, and therefore we need to rationalize. You may lose marks in high school if you don't do it. To rationalize really means here multiply and divide by square root b, right? So just multiply and divide by square root b. So what you get here as a times square root b in the numerator, and the denominator will be square root b times square root b, which is b. Perfect. So what you learn here is that when you multiply any number square root n with square root n, in that case we get n square root, which is equal to n, since we know that n is greater than equal to 0. If n was negative, then square root of n will not be a real number. You get the whole idea, right? Now let's take up the part b, which is slightly tricky. We have a over b minus square root c. How do we rationalize this? So to rationalize, what we do is we multiply and divide by its conjugate. So the concept here is to multiply and divide by conjugate. Now what is conjugate? Here you can see what is conjugate. We'll rewrite this expression a over b minus square root c. The conjugate is b plus square root c. So we'll multiply and divide by b plus square root c. So in the numerator, you get a times b plus square root c. And in the denominator, we have b minus square root c times b plus square root c, which is b square minus c. Right? So that is how we have removed the square root part from the denominator. So this is rationalization of the denominator. Get the whole idea. So the concept here is that, let me write general terms, x plus y times x minus y. It is equal to x square minus y square. You get the whole idea. So you get b square minus square root c square, which is c. Perfect. So I hope the concept is clear. Now let's begin with part C. You can always pause the video, answer these questions. So here we'll multiply and divide by conjugate. Conjugate will be 3 minus square root x, right? So we are given 9 minus x over 3 plus square root x. We'll multiply and divide by the conjugate, which is 3 minus square root of x. Now, when you do the same thing in numerator and denominator while multiplying, then b is multiplying by 1. You're not really changing the expression, right? So you get 9 minus x times 3 minus square root x in the denominator. If you want, you can write 3 square minus square root of x square, right? So let me write here. We get 9 minus x times 3 minus square root of x over 9 minus x. So 9 minus x, you can see, cancels. Because of that, we get 3 minus square root of x. You get the whole idea. So that becomes the solution after rationalization. This is a very simplified term. So we use the term rationalize and simplify. Here's the next question, slightly more complicated. We have x over square root of x plus 1 minus 1. So what is the conjugate with which you should be multiplying? The conjugate here is square root of x plus 1 plus 1, correct? So we are going to multiply by square root of x plus 1 plus 1 in the numerator, square root of x plus 1 plus 1 in the denominator. So what you get here is x times square root of x plus 1 plus 1 divided by a square minus b square. So you get x plus 1 minus 1, right? So you can open this bracket in the denominator. You get x times square root of x plus 1 plus 1 over x, right? Because plus 1 minus 1 becomes 0. Now you can cancel x, right? And you get your final result, which is square root of x plus 1 plus 1. You get the whole idea. That is rationalization. So you see how we have come to a slightly more difficult question. Now here is a very important expression before you. We need to rationalize square root of 4 plus h minus 2 over h. Now when you begin with calculus, this is going to be almost your first question. Now let's rationalize. To rationalize, we'll multiply and divide by the conjugate, which you know is square root of 4 plus h plus 2, right? So that step is multiplying, dividing by the conjugate of the numerator. So this time we have rationalized the numerator. Do you understand? And when you do that, what do we get? Square of the first part, so it is just 4 plus h, right? Minus square of 2, which is 4, over h times square root of 4 plus h plus 2. Now you can see 4 plus h minus 4 is only h over h times square root of 4 plus h plus 2. As you can see, h and h will cancel, and therefore we can rewrite this expression as 1 over square root of 4 plus h plus 2. You get the idea. Remember, if h is in the denominator, we know that h is not equal to 0, right? So important thing here to notice is that if I put h equals to 0 in the expression, I get 0 over 0. So this 0 over 0 is called indeterminate form. And see here in the last expression, if you put 0 for h, you get a value, right? 1 over 4. So that concept will be used with limits in calculus. Here's the last question for you. Here you see radicals in both numerator and denominator. So we need to rationalize both numerator and denominator, right? So there we need to rationalize. Perfect. See, in this particular expression, we know that x is not equal to, here we know x is not equal to 2 because that will lead denominator to 0, right? Okay. And what you also notice is numerator is also 0 for x equals to 2. So it is a 0 by 0 expression. We call that indeterminate. So that concept will be used in limits in calculus once again. I'm telling you this because you're soon going to apply this strategy. Great. So let's copy the expression, which is square root of x plus 2 minus 2 over 2 minus square root of 2x. So this is a part of pre-calculus because you are learning strategies which will be useful for you in calculus. Great. So let's rationalize both numerator and denominator. So when I want to rationalize numerator, I'll multiply divide by conjugate of numerator, which is square root of x plus 2, right? Square root of x plus 2 plus 2. And also, I'm going to multiply by the conjugate of denominator, which is 2 plus square root of 2x. You get the whole idea, right? So that is what you get. And now, when you expand and simplify, so these two terms, when you multiply, what do you get? You get x plus 2, right? Minus 2 square, which is 4, as the first term. And then you're left with 2 plus square root of 2x. In the denominator, 2 minus square root 2x and 2 plus square root 2x will get simplified. So we get 4 minus 2x, right? So let me write this 2x in the bracket times. So this is one term, the other term is square root of x plus 2 plus 2. Makes sense, right? Now see, we have x minus 2 in the numerator. X plus 2 minus 4 gives me x minus 2, right? And here we have 2 plus square root of 2x. And this expression, 4 minus 2x, I can take 2 common. And we get 2 minus x as my term. And then we'll multiply this by square root of x plus 2 plus 2. You get the idea. Now this cancels with term negative 1. You see that? And you can simplify and write down your answer. So your answer here will be 2 plus square root of 2x, and all this will be minus since we divide this by 2 minus x, and the term in the denominator will be 2 times square root of x plus 2 plus 2. Makes sense? So I just squeezed it in as the space was not enough to give you the solution. Perfect. So let me rewrite the answer here. We get this whole expression. Let me erase this now. So this expression is now equal to minus 2 plus square root of 2x divided by 2 times square root of x plus 2 plus 2. Correct? And of course, x is not equal to 2. That still remains the restriction for us, right? So I hope this concept of rationalization is absolutely clear. We read six examples, very wide variety, starting with basics which you need at middle school level, and as you go ahead, more complicated cases will be dealt with, which have been discussed here. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.